Hi class. Now for this discussion for Module 2, we're doing the quadratic challenges. We're going to access the activity Match My Parabola, and this is through Desmos. And so I'm just going to go ahead and click on this link, and because I already have an account in Desmos, that's why it had my name, and then I'm going to go ahead and match my parabola. All right, so the directions are, now they said I could go straight to number 8, but I just kind of want to look through all these. For each Match My Parabola challenge, plot a parabola that passes through the given points and continue in the next screen to get started. Okay, so plot a parabola through the points. So try typing y equals x, and then I want to go to squared. So notice how I have the, I clicked on the keyboard, the keypad button, and then I can do that. And look at that, that goes right through the points. So I'm going to submit that, and then I'm going to go ahead and go to the next one. It says plot 5 parabolas, one through each set of colored coordinate points. One is done for you. So the red one is going to be y equals x squared. Now I want to try to do the blue one. Now notice how we call this area the vertex, and notice how the vertex moved up 1, 2, 3. So if it moved up 3, then it's going to be y equals x squared plus 3. And I'm going to hit enter. And then let's go ahead and do the green one. Now this one has moved over 4 to the right. So if it moves over 4 to the right, then that means that the x squared is going to be inside the parentheses. So y equals, I'm going to put parenthesis x, and then it's going to be minus, oops, it's going to be x. And I think I'm going to have to use, I'm going to have to use the minus sign that's in the keypad, minus 4, and then I put the end parenthesis, and then go ahead and go square. And I'm going to go ahead and check my work on that. Look at that. I've got them both right. So now let's go ahead and do orange. Now orange, it went down. The orange one went down 3. So now I'm going to do y equals x squared, and then minus 3. And then I'll check my work, and then let's go ahead and do the purple one. Now the purple one went over -4. Now see how the green one, it went over +4, so I had to subtract 4 from it. And then for the purple one, I have to go, it goes to the left -4, so this one I'm actually going to add 4 to it. So y equals x plus 4 and squared. Now, one of the way to remember that, if it helps you remember, see these points are on the 0, which means it's on the x. So when you think about it, like for example, green, the reason why I put x minus 4 is because that the vertex is at 4, 0. So if I put 4 in, then 4 minus 4 is 0. So that's why if you subtract it inside the parentheses, it goes to the right. If you add it inside the parentheses, it goes to the left. If you're adding it outside the parentheses, it goes up. And if you're subtracting outside the parentheses, it goes down. All right, so now let's look at the next one. Consider these graphs. Eric thinks the equation is y equals x minus 3 squared will match the blue graph. Jenny thinks it will match the red graph. So remember what I just said with the x minus 3? So if it's minus 3, it has to go to the right. So actually the one that is red, so it's going to be Jenny. And the reason is because if I take 3 minus 3, that equals 0. So it will match the vertex. And then I could share with class. Okay, so now let's look at my next one, number 5. Again, plot 5 parabolas. Each parabola should pass through the origin and pair of colored coordinated points. One is done for you. So the red one, y equals 3x squared. Now, I want you to notice how when you have a coefficient in front of the x squared, that v, that parabola, actually gets really skinny. When you have a lower number or a fraction, then that parabola actually gets larger. It gets like to be a larger u. So let's look at first the blue one. Now the blue ones, we need to know which parabola goes through there. Now for the blue one, notice how that one's going to be a little bit larger. So right away I'm thinking it is going to have to be a fraction, and that's going to be the coefficient of the x squared. Now unfortunately I don't see the vertex of it, but my guess is it's going to be at that 0 mark. So what I'm going to do is I'm going to count 1, 2, 3, 4, 5 lines over. So this could be y equals 1/5 and then x squared. Whoops. And then x squared. And let's give that a check. Check my work. Look at that. So it's 1/5 x squared. So do you know what? Now let's look at the green one. Now the green one, notice how this is on the bottom, okay? And notice how it is about the same, or what we would call a parent function, but it's negative, which means it's going to go down. See, all those parabolas that we've been doing have been going up, which means it looks like a U, but these ones look like they're going to be going down. So I'm going to do y equals negative x squared, and I'm going to check my work and look at that green one. That one went really well. So now I'm going to go ahead and look at these orange ones. Now again, this one looks like it's going to be a little bit thinner than the y equals x squared, and so I'm going to try, now again this one's going to go down, so y equals negative 2x squared, and let me check my work and look at that orange one that goes down. Now the reason why I chose negative 2 is I looked at the negative 3 one, and that was, I looked at the positive 3 one, that was real skinny, and then I looked at the 1, and so I figured it was in between the two, so I tried negative 2. Now let's go ahead and do the purple one, and the purple one, again, as they get larger, then you have a fraction, and I'm going to try this one as 1, 2, 3 as maybe 1/3, but remember it's going to be negative because it is going upside down, so negative 1/3 and then x squared. And check my work. Oops, now notice how I did not do that right. It was not as wide as it needed to be, so I'm going to change that to 1/4. And I'm going to check my work. And look at that, I'm still not where I need to be. So again, I'm going to go 1/5 and check my work. I'm almost there. And actually, I think I'm going to go ahead to go to 1/6. And then that one worked. Now notice though, I want you to see something. I'm going to go back to 1/3. 1/3. Notice how that is not as wide, and so all I did was I kept increasing that fraction, or increasing that denominator, which is actually making the fraction smaller. So 1/5, and then I go to 1/6 and check my work. All right, so now let's go into the next challenge, challenge number 4. Plot a parabola through the points. When you finish, check your work. So now here's the vertex. The vertex is here. Notice how it lines up. This is 4, negative 2. So the vertex moved over 4 and went down negative 2. See, those are the keys. Over 4 and down negative 2. So knowing what we've done before, if it goes over 4 and then down negative 2, so this is going to be x over 4 is minus 4, and then we're going to do squared, and then down negative 2, so it's minus 2, and let me check my work. So as I notice, it goes through the vertex is fine, but notice those other red points, those are not there. So as we've done in the previous challenges, this makes a U, but we need to make it larger. Remember, it gets smaller when the coefficient winds up being larger, like 3, 4, 5, 6. And if you make the coefficient smaller, like right now the coefficient is 1, but if we go 1/2, 1/3, then it's going to widen out that U. So I want to show you this real quick. So if I put a 2 here, check my work, notice how that's become thinner. That vertex has become thinner. So what I'm going to do is I'm going to go ahead, again back to 1, and notice how that is gotten fatter than the 2. So I'm going to go 1/2, and I'm going to check my work. See, the good part is that they do give you those points, and that really does help you. Okay, so now number 7. Adjust the equations to create 3 different parabolas that pass through the points. So we need to adjust these equations to create 3 different parabolas that pass through the points. Now with this one, again, we're going to look at the behavior of the graph. The 2 points that they want us to pass through is this point right here, which is 3, 0, and then this point right here, which is -4, 0. So let's look at the red one first. So the red one, we need to make it pass through these 2 points. So what I'm going to do is, see how it says +2, so it's over here. So what I'm going to do is I'm going to change that to +4, and notice how that moved over to -4, and then this one I'm going to do x -3, and that pulls it through that one. So now my red one's done. Now let's look at my blue one. Now my blue one is upside down, so it already gives me that -2. So I'm going to go ahead and do +4, and there we go, and then -3, and it's through that point. And now we have the y equals 1/5, x + 2, x - 2, so I'm going to go ahead and change that to +4, and then -2 is now +3. All right, so now let's look at challenge number 6. Plot 5 parabolas, 1 through each set of color coordinated points. So let's first look at the red one. The red one, here we have the vertex is down here at -1, and then we have the 2 sides. One is at -5, and the other one is at -7. So now let's look at the red one, and we have the one at -5, and we have the other point at -7. So I am going to do y equals, and then parenthesis, x + 5, and then x + 7. And now I'm going to check my work, and that parabola goes through. Now, the reason why I chose +5 and +7 is, and I believe you read this in your learning, we call that the zero property principle. In other words, when are those x's 0? So if I were to say, and I'm going to go ahead and pull up a whiteboard right here, if I were to say x + 5 and then x + 7 equals 0. So that means this is going to equal 0, or this is going to be equal 0, right? Because if anything is multiplied by 0, then it's going to be 0. So I could do x + 5 equals 0, or x + 7 equals 0. So then I would solve. So subtracting 5 from both sides, this would be x equals -5. And this would be x equals -7. And notice that's exactly where my points are. Okay, so now let's go ahead and try the blue one. The blue one is going upside down, and so we know it's got to be negative. And so I noticed that the 2 points, one is at a -2 and one is at a -4. So it's going to be y equals, and I'm going to put a negative sign in front of it, negative, and then I'm going to do x + 2 and x + 4. And let's go ahead and give it a try. And look at that, my blue one works. All right, so now let's look at my green one. My green one, I have my 2 zeros, one's at 1, one's at -1. It looks like it's going up because that vertex is below, so it's going to go up. So then y equals, and then it's going